Okay, so we're back with video 2 here. So maybe you could get these coordinates without drawing your triangle. Maybe you needed to draw it. It doesn't matter. Just as long as you can see that triangle in your first quadrant, and if you flip it over, you can see how it's mirrored, how this side is still root 3 over 2 and this side is 1/2. The reason we have to put the negative there is because you're traveling left from the origin, okay? And then you're still going up. Then if you flip it over the x-axis, it gives you this triangle. And again, important thing, hypotenuse always 1, right angle always on that x-axis. So when you flip this over, this side is still root 3 over 2, except now you're going down. You're still going left. That's why they're both negative, okay? And then when you flip it over here, still your vertical distance is that root 3 over 2. Your horizontal distance is still the 1/2. The one that's negative is the vertical because you're going down, hypotenuse still 1. Okay, so that's using your properties of your 30, 60, 90 to get those 4 coordinates on your unit circle, these 4 coordinates on your unit circle. Okay, and the ones that are left are the ones in the middle, as well as what's called quadrantal angles, meaning the angles that are on the x and y axes. Okay, so we're going to look at those next. So those ones in green are going to be the ones that we'll fill out. Again, if you can visualize the side lengths, and when you're looking at like this, the blue triangle, it's very clear that this horizontal distance is a lot shorter than the vertical distance, okay? 1/2 is 0.5. Root 3 over 2, plug in your calculator. It's about 0.86. 0.86 is larger than 0.5, but 0.86 is smaller than 1, okay? So if you can visualize which side is smaller versus which side is your medium size, it's going to help you learn these coordinates really, really quickly, because in the end, you are going to know them, okay? So let's move on to reviewing our 45, 45, 90 triangle. So in geometry, what's important about a 45, 45, 90, it's isosceles, okay? Meaning these sides are equal. So what you would have learned in geometry is that it was x, x, x root 2. Your teacher also could have said, we're just going to set up proportions and say this is 1, 1, and this is 1 root 2. Okay, root 2 is a little bit more than 1. Now, when we place this into our unit circle, we know our hypotenuse has to be 1. Okay, so let's go ahead and take a look at placing our unit circle here. Okay, so here it is. So let's take a look at that 45, 45, 90. That means that the base is going to be equal to our height, and we know that because it's an isosceles triangle. And when those are both 45, you know that the sides opposite must be equal, okay? Again, important, our radius is 1. So let's take a look at that off to the side, and we'll choose the one dealing with the x's. So this is x, x, x root 2. Well, we know that when we place this into our unit circle, your hypotenuse must equal 1. So what we need to do is solve this for x to figure out the missing pieces. If I solve that for x, I divide both sides by radical 2, and I get it, x equals 1 over radical 2. We will always rationalize this, so that means we want to multiply top and bottom by the same number, and that gives us root 2 over 2. So that's going to be this, and that's going to be this. Okay, so this piece here is root 2 over 2. This piece here is root 2 over 2. What does that mean? It means this coordinate, we're going right root 2 over 2, we're going up root 2 over 2. What's awesome about our 45, 45, 90 points? They're the exact same values. The only thing that's going to change is the sign based on the direction of our triangle. Which quadrant is it in? So are we going right and up, meaning everything's positive? Or are we going left and up, meaning our left distance is negative, our up distance is still positive, hypotenuse still 1, our coordinate, negative root 2 over 2, positive root 2 over 2. Okay? Right angle, always on the x-axis. Now we flip that over. We're still going left, so that's negative. But now we're going down. So now both here are negative, just like they were with the 30-degree inside angle and the 60-degree inside angle. Because the positive and negatives just come from direction. You're going right, your cosine's positive. You're going left, your cosine's negative. You're going up, your sine value is positive. You're going down, your sine value is negative. And then if we flip it over here, you're still going right, which is positive. Because remember what coordinates are. They're telling you where is this point compared to the origin? Where do you go? If it's positive, you go right. If it's negative, you go left. And then your y value, if positive, you go up, negative, you go down. So now here we're going down. And that's why that is that. Okay? So now we know all of those points. Okay? You know all the red ones. You know all the ones in blue. And you know the green because you're looking at them. The ones that we're missing, I'll go ahead and color them in yellow. I won't label them that way. But remember, this is just our unit circle. Okay, so remember what your unit circle is. Picture a regular graph, right? Like this. And it's a circle of radius 1. Just looks like that. Those points that I have highlighted in yellow over on my unit circle are these coordinates right here. Those should be the easiest ones for you to label. Think about this. You're going right 1, you're not going up or down. So that's 1, 0. Then the one on the y-axis, you're not going right or left, you're just going up. It's 0, 1, right? You're not going left or right, so it's 0, and you're going up in the positive. Then this one right here corresponds over here. That's your negative 1, 0. And this one right here is your 0, negative 1. So again, picturing it on this graph over here, don't forget what you learned back in probably early junior high, okay? Those beginning coordinates, and that's all those are. Those are called quadrantal angles, okay? So those 4 that are missing, or that we just added in black, they're called quadrantal angles because the coordinates lie on the x and y axes